Hello! This video will cover section 4.2, pages 22 through 28. Alright, let's go ahead and get started then. So in section 4.2, we were considering different measures to summarize the relationship that we have in these 2x2 tables, or in these mosaic plots that we've been creating. So here we have, again, information from the Donner Party and whether or not they survived. So that is my primary response here. No, they did not survive, or yes, they did. And then I'm making comparisons across two different camps here, Alder camp on the left and Lake camp on the right. So let's go ahead and consider our questions here. What is the risk of death? So that is going to be survived equal no for the Alder camp. So survived equal no is going to be the black boxes on this display. And we can see that Alder camp's on the left. So the risk of death there is 52.2%. For Lake camp, that risk goes down a little bit and is reduced to 42.4%. So one of the summary measures that we talked about was the risk difference, and that's simply the difference between those two numbers. So if I wanted to compute that value, that would just be the 52.2% minus the 42.4%. Just grab my calculator here, and we can use that to complete that math. So it's 52.2% minus the 42.4%. And that risk difference is 9.8%. Now, when we do the differencing, that percent stays with us. Okay, so interpretation of this value would be that the risk of death at the Alder camp was 9.8% higher than the risk of death at the Lake camp. Okay, so now let's go ahead and compute the ratio. The ratio is another way to make comparisons between those two. And again, that'll just tell me how many of the smaller boxes here will fit inside of the larger box. So to do the ratio, we'll use the same numbers, 52.2%, but then we need to divide by 42.4%. So let's grab the calculator again. So 52.2 divided by 42.4. And I get about 1.2. Now this, again, is not a percent like we talked in class. Because it's a ratio, the units actually cancel each other out. So the interpretation here is the 52% is in the numerator, so that's Alder camp. So we would say the risk of death for Alder camp is 1.2 times larger than whatever you have in the denominator. And the denominator is the risk of death at Lake camp. So the risk of death at Alder camp is 1.2 times larger than the risk of death at the other camp. So that would be the interpretation there. And a risk difference, I should probably write out the interpretation there. The risk of death for Alder camp is about, or is, I guess, if we want to use the exact values, 9.8% higher than, and then the other box, which is the risk of death at Lake camp, or for Lake camp. Okay, so that's the two interpretations of those, and those are both equally good methods of describing the differences between the risk of death at these two locations. All right, let's move on to the next example then. This example is about people that have been killed by dogs in the United States. I believe this was over a 2 or 3 year period, if I remember right. I don't think it was for just one, yeah, over a 2-year period here. Okay, so this is the data that was presented in the report, and we need to take this data and put it into a format that we're comfortable with or that we would use to create these plots. So what I have here is a table that I'm interested in looking at, and I want to look at whether or not pit bull was the cause of the death. And I'm going to do that for 2 different age groups, adult and children. So let's look at the right side here. I have people that were killed by pit bulls. So I need the children that were killed by pit bulls, and I'm going to use the first 4 age categories. So they didn't stop the ages there at 18, they actually went to 20. So I'm going to call somebody that's 20 and younger a child here for this discussion. So I have 2 in that age group, 7 from 5 to 9, so that's 9 total, 19, and then what, 24? So for the pit bulls, 24 children were killed. So that would be this number right here. Children, pit bull was the cause. And then for the adults, I have 2 age groups. So there's 14 there and 20, looks like 14 and 14, that's 28. So for the adults that were killed by pit bulls, that would be 28. Now let's come over here and look at others. These are non-pit bull victims. So it might be easier here to do the adults first. There's 12 there, it looks like. So adults, non-pit bull would be 12. And then there's 36 total, so that leaves 24 here in those other age groups. So this 36 here should match the non-pit bull victims. And this over here, the 28 and the 24, should add up to the total for the pit bulls here. Looks like I have 48 in that category, and 12 plus 28 is 40. So that's how this table would be created. And then we could use this table to create this 100% stacked column graph, or the Mosaic plot. And what we would be interested in comparing here are the gray boxes for the adults compared to the gray boxes for the child, because that's the situation where pit bulls were the cause of death. All right, so let's jump in here. The proportion of adults that were killed by pit bulls is about 70%. So if we look at our graph here, that's about 70% there. How was this computed? So again, that's going to be a row percent, and we are simply going to take, if I'm interested in the adults, in pit bull, yes, that quantity is going to be computed by taking 28 divided by 40. So again, if I get my calculator, 28 divided by 40 should be about 70, it's exactly 70%. Okay, so that's how that bar is computed there again. So 28 divided by 40 is where that 70% is coming from. What proportion of the children were killed from pit bulls? So how I would compute that, right, would just be this box here. That's going to be child pit bulls, so that's 24 out of the 48, which is just half of them. Okay, so the percentages, or the math there, I guess, if it's asking for the math, would be 24 divided by the 48, which is just the 50%. Now, is it true that adults are more likely to be killed by pit bulls than children? It is. This is 70% here, and it's only 50% here. Use a risk ratio to express the increase in the risk of fatalities due to pit bulls for adults compared to children. So if we wanted to do a relative risk ratio there, all I would need to do is take the 70%, and divide that by the 50%. And when I do that, again, grab my calculator, divide by the 50%, I get 1.4. Okay, so again, if we want to interpret this, what do I have in the numerator? The adults here. So we would say adults are 1.4 times more likely to be killed by a pit bull than a child. So the adult here is in the numerator, so I put that first here when I'm trying to understand what's going on. Suppose you work for the Winona County Humane Society. How might this information be useful to develop a flyer for new pit bull owners? Well, we should make sure that they know that of everybody that was killed by pit bulls, okay, or excuse me, 70% of the dog deaths, let's go up here, 70% of the dog deaths in adults are by pit bulls. So we do have to be more careful with those particular breed of dogs than maybe other dog breeds. But in children, it's equally likely to occur, the pit bull being the cause versus some other type of dog being the cause. And that might be true. I mean, that might make sense, excuse me, because adults are handling their dogs a lot more than children are, and probably even more so when the breed is a pit bull. So if they're handling them more, then we would expect that the risk of death might be higher. Let's talk a little bit about something that can be quite confusing out in the real world, and that is the notion of the additional risk. So if we do a risk difference on this box was 70%, we said, and this box was 50%. So that difference is 20%. So if we want to talk about the notion of additional risk, one way that we could do that is just that it was increased by 20%. However, the ratios, not differences, but ratios are used a lot more in the real world. Okay, so we tend to say things like we said here, that adults are 1.4 times more likely to be killed by pit bulls than a child. Those statements are much more common in the real world than saying it's 20% higher. So ratios are used a lot. Now, why this can be confusing is, so this box right here is 1.4 times larger than box B here. Okay, so that means 1.4 of this B box will fit inside of the A box. It takes 1.4 of the B boxes to fit inside the A box, or to be as tall as the A box. So some people will say that, so 1.4, that extra 40.4, they'll convert that as a percent, and they'll say this box is 40% larger than this box. And when you're doing a relative risk ratio, that is a correct or okay thing to say. That box A is 40% larger than box B. But that's confusing if you also are thinking about risk differences. So this box is, if you think of just the differences, it's 20% larger. So some people will say that box A is 40% larger, and that is correct if they're doing relative risk ratios. But if somebody else is doing a risk difference, they're only going to say that the box A is 20% larger. Now, both people are right. It's just, how are you basing that percentage? Are you doing that as a difference? Or are you doing this as a risk ratio and then looking at that additional amount? So there is, to say the least, considerable confusion when people try to talk about the notion of additional risk. And you really need to try to figure out, I mean, in order for us to, how do I handle this in the real world? You need to ask them, are you talking about the difference in the risk? Or are you looking at the risk ratios and talking about the additional risk off of that ratio? Now, they just say something like it's 40% higher. They don't tell you which way they actually calculated that. So that's why this is so confusing. And to me, as a statistician who tries to help people communicate with data, this is very confusing. Most of the time out in the real world, when they say that box A is larger or 40% larger, they're talking about this. They're not talking about differencing, even though I think differencing makes a little bit more sense and is easier to understand. All right, so no solution for that, but just understand that there's considerable confusion around that in the real world. All right, so let's look at a study here about, what are we looking at here? Risk factors and for osteoporosis. So certain risk factors for osteoporosis. There's a long list of these. Looks like there's 19 different risk factors. And these are postmenopausal women here that we're talking about or looking at. So let's look at just one of these, maybe the first one. 1.27 is the risk ratio value. And that is for mother with fracture. So what is the chance that a postmenopausal woman is going to end up with a fracture? We're going to break that into two different groups. Did their mother or has their mother had a bone fracture? And then the other group is that her mother has not had a bone fracture. Okay, so has had a bone fracture is in the numerator. So what is the chance that a postmenopausal woman is going to end up with a bone fracture? If the mother had a bone fracture, their risk increases a little bit. They are 1.27 times, have a 1.27 times higher risk, okay, of having postmenopausal osteoporosis. Compared to the other group was mother that did not have a bone fracture. All right, so let's try one maybe that's a little bit less confusing. Relative risk diabetes is 9.17. 9.17. So if you're looking at the chance that a postmenopausal woman's going to end up with osteoporosis, that's my response here. Okay. They are 9.1, a woman with diabetes is 9.17 times more likely to end up, okay, with postmenopausal osteoporosis than a woman that does not have diabetes. Okay, so that is, diabetes here is a very good indicator of bone density or weakening of bone density. Okay, that is the one that is the largest in this list. So what that means is diabetes, of all of these 19 risk factors, diabetes is the most important or most indicative of bone strength in postmenopausal women. And if you have diabetes, okay, your risk goes way up. Okay. How about African American? African Americans actually less than 1 here. So if a woman is African American, their risk of postmenopausal osteoporosis or a fracture of some type is actually reduced. We usually create these so that these are larger than 1. So what I can do here is just reverse that. So let's take, instead of using 0.54, let's take 1 divided by 0.54, and I'm going to get about 1.85 or 1.9. So if a woman is not African American, their risk of postmenopausal osteoporosis goes up by 1.9 times compared to African American women. So again, we usually calculate these things so that they're larger than 1. They happen to not do that in this table. But we can always just take 1 divided by that, or just flip what they put in the numerator and denominator. And mathematically, all that means is we take 1 divided by the number that they're giving us. And again, in this particular case, that number was 1.9. But if I'm going to flip the order around, then I have to talk about non-African Americans are 1.9 times more likely to end up with postmenopausal osteoporosis than an African American woman. The one that is least important in this list is the one that's closest to 1. So if I were to ask that on a test or something, I don't know, I have 882 here. 1.09 is pretty close there. That is smoking former. I think that is the closest one to 1. So being a former smoker, does not really increase one's risk of a fracture or postmenopausal osteoporosis, because that's pretty close to 1. Remember, relative risk ratio close to 1 means there's no difference in the risk. However, when you look at the current smoker or more than a half a pack a day, if we have a woman, postmenopausal woman, that is smoking more than a half a pack a day, their risk of a bone fracture goes up by 3 times. So smoking certainly has an effect on bone density and the risk of postmenopausal osteoporosis. All right, let's talk about this example, the last one in this section. This is actually from the Minnesota Department of Corrections. And this data is probably 10 or 15 years old. So it's a little bit older, but it was a really neat study that they did. And what they did is they wanted to evaluate the effectiveness of sex offender treatment programs within the Minnesota Department of Corrections. So somebody was a sex offender, we put them in jail or in prison, they were sent to prison. They had programs for them to try to prevent them from committing another sex crime if they were to get out. So they wanted to look at the effectiveness of these programs. Okay, they took 2,040 sex offenders, okay, and put them through the sexual treatment program. So there was a total of 2,040 sex offenders that went through the sexual treatment program. And then what they did is they also took another 2,000, of those 2,040, so let me take that back. There were 2,040 people in this study. 1,020 of them went through the sexual treatment program. That's this line here. But what they did is they tried to match those people with people that did not go through the sexual treatment program. So they were matched on commonly known risk factors. So maybe what age they were. All right, so this is another match paired study. They had 1,020 people that went through the sexual treatment program. They had another 1,020 people where each person in this study here or in this group was actually matched with the person that did not go through the sexual treatment program. And then they just kind of tallied up the best they could the number that were not rearrested and then the number that were rearrested. And we actually have that for the reason as well. So this 145, what does this number represent? That's 145 people that went through the sexual treatment program actually were rearrested for a sex crime of some type. 314 of the 1,020 people that went through the sexual treatment program were rearrested for some sort of violent crime. So these people here were rearrested. There's 443 that were not. Now, we cannot, so why can't we use computations of relative risk in this study? We cannot use computations of relative risk because I have forced the groups to have the same number of total observations here. So it's not fair to use those calculations in a relative risk ratio. What we do with a relative risk ratio, right, is we take some number and divide it by the total. Well, these two numbers or these two totals have been fixed. I've determined what those are. And in that situation, we don't want to use those totals in a calculation. What we're going to do instead, though, is use an odds ratio. So an odds are going to just compare those numbers there against this number over here. So let's compute our first odds here. The odds of a rearrest for a person in the sexual treatment program, odds of a rearrest, that's what I want to calculate. So I need to add up how many were rearrested. So that's the 145, 314, 118. Okay, that's 577 people were rearrested. 443 were not. So this number is bigger than this number. So that tells me that more people were rearrested. Okay, more people came back to prison than did not come back to prison. Let's compute those same odds for those that did not go through the sexual treatment program. So there, I'm going to have to, let me just copy this down here. That'll be a little easier for me. It's going to be 199, 348, and 46 on that group. And the number that were not rearrested was 427. Okay, so let's go ahead and get those numbers. So that's 427 there. How many were rearrested? That's going to be 199. Let me get my calculator. 199 plus 348 plus the 46. So 593. 593. So this is the number that were rearrested, and this is the number that were not. Okay, so we can see that those that did not go through the sexual treatment program, we do have slightly more that were rearrested. I mean, the best case scenario for these odds would be 0 colon 1020. All right, because then that would say that nobody was rearrested. But you're not going to find a program, sexual treatment program, that is going to perform that well. That's the goal, is to get 0, 1020. All right, so let's compute the odds here of a rearrest. Okay, so let's go ahead and do this. So to do the odds, I need an odds ratio, excuse me. I need to figure out how to compute this so that I get it bigger than 1 here. So I'm going to take 577, I think, and that'll be the odds for those that went through the sexual treatment program. And then I need to divide those odds by 593, 427. Okay, now I can't, like I said in class, we can't do anything with a colon on a calculator, so what we end up doing is just taking the ratio of these two ratios here. So we're going to divide that, and once we get that number, we're going to divide by this other ratio here. So maybe group these things up a little bit. So let's do 577 divided by 443 first. Let's do that one first. Get my calculator going here again. 577 divided by 443. That's going to be 1.3. Not 13, 1.30. And I need to divide that by the other ratio here. So that is going to be 593 divided by 427. Oops. And that's going to be 1.38. Okay, and I did this, unfortunately, I did this backwards. So let me just, we want to put these odds in the numerator because this thing is going to be less than 1. And it's always easier to talk about these quantities when the thing that I'm calculating is bigger than 1. So if I do it this way, I'm going to have 1.38 in the numerator and 1.30 in the denominator. Okay, so let's go ahead and figure out that last 1.38 divided by 1.30, and I get about 1.06. The 593 and the 427, those are the odds coming from not in the sexual treatment program. So let's interpret this here. What goes first? For a person not in the sexual treatment program, that's the numerator here. The odds of a rearrest are 1.06 times higher than the odds of a rearrest for a person who went through the sexual treatment program. Okay, so that's what we're looking at here. Is somebody that went through the sexual treatment program, the odds of them being rearrested are 1.06 times higher than someone that did not, or that's compared to someone that did go through the sexual treatment program. So, good news, I guess, here. This value is bigger than 1. Remember, we're doing a ratio, and when that's bigger than 1, okay, then it means that the odds in the numerator are higher, or whatever I'm looking at in the numerator, which is odds of rearrest for somebody that did not go through the sexual treatment program. So this means the sexual treatment program is working a little bit, maybe, because a value of 1, the bad news, the bad news is this value is very close to 1. 1.06 is not very much bigger than 1. If this quantity right here is 1, that means the odds are the same between those two things, and that means the sexual treatment program isn't doing anything. And 1.06 is not very much, like I said, is not very much larger than 1. So we can say that the sexual treatment program is working, it's just not working very good at all. And this is a sexual treatment program that, again, this is coming from the state of Minnesota. We did this with people in prison over many, many years. And I'm sure this program cost a lot of money to run. We're not talking $10,000. We're probably talking hundreds of thousands, well, I don't know, tens of thousands of dollars, maybe hundreds of thousands of dollars. If this is run over many different prisons, over many different years, we're probably talking a lot of money here. And we're not really getting a very good value for that money spent if the odds are at 1.06. And they knew that. That's why the state of Minnesota knew that. That's why they did this study, or one of the reasons they did this study. Now, this is data, like I said, is somewhat older. I do not know what they're doing more recently with the sexual treatment programs in prisons in the state of Minnesota. Here's another one from Sweden, I guess. And these odds ratios, you can see where my cursor's at here. Ones that are large or far away from 1 are going to be important. Indicator of recidivism. Recidivism is just the word that they use for somebody coming back. So you can see in Sweden they have things called score of 1, 2, or 3. In the States we do have a level 1, level 2, or level 3 sex offenders, so it's probably something similar. And you can see that for a level 3 sex offender, at least in Sweden, the rate that there's a 27, the odds of them coming back for a sexual recidivism, so this is for a sex crime, the odds of them coming back are 27 times higher. That's a lot. So when we go to release a level 3 sex offender, what that's saying is their odds that they're going to recommit another sex crime, at least in Sweden, is really high. So we want to be very, very careful when we release a level 3 sex offender back into society. I don't have these numbers for the United States, but I'm sure they're similar. Which ones are not very important? Young age. So if an individual was sent to prison in Sweden between the ages of 18 and 24 or 25, the odds of them coming back for a sex crime are actually less than 1. So that's good news. This is the sexual recidivism, and then this is any violent crime over here. We could have done a more fair comparison up here, I guess, now that I think about it. What Malone did is I took all of these and added them up. What might be a more fair comparison is just doing the sexual crimes. There came back, the reason for the rearrest was for a sex crime. So if you're trying to evaluate now that I think about it, if you're trying to evaluate the appropriateness of a sexual treatment program, maybe I should just be comparing that 145 to that 199 number. So instead of computing odds of a rearrest, what we would compute is the odds of a rearrest for a sex crime. And then do the odds of a rearrest for a sex crime down here and compare those two odds ratios. That might be better than what we did here with that 1.06 number. I'll leave that up to you guys, though. If you want to play around with that and look at that, you certainly can. Okay, that does it then with pages 22 through 28 of section 4.2. Thank you. Have a good night.